converge the rays of light at a common point. So depending on this, we'll be using the sign conventions. So convex lens, it's a converging lens, and both the lenses, they are based on the phenomena of refraction of light. Okay. So have we done the ray diagram or image formation by these lenses? I think we have done all the ray diagrams and image formation by these. Okay, so let's both these concave and convex lenses, they are based on the phenomena of refraction of light. So we had seen the different ray diagrams for the image formation by lenses. So just as a quick recall, I'll be giving you an idea for all the different images which we had seen. Let me see if we have the lens. Yeah, image formation. This one. I think we have. So we had done this. Okay. So this is all what we had done. We haven't done in detail that at what position which image is being formed. That is not done. This is the only thing that we have done about the converging lens and the diverging lens, right? Okay. So let us see how the images are formed for a convex lens. Image formed by a convex lens for various position of the objects. So how many of you can draw the image positions for various positions of object for a convex lens? Yes. Can you draw the position of image for the different positions of object? Yes. Can we draw? No, I think we shall continue then from here only. Position of images for various positions of object. Okay. So the position of image for the various position of objects. Let's see what are the different or various positions of the object. So at first we keep the object at infinity, and we had seen when the object is at infinity, the image is formed at focus. Then the second ray diagram, we keep the object beyond 2f. So we had kept the object beyond 2f, where we observe that the image is formed between f and 2f. So let's try to draw the diagram when the object is placed beyond 2f. So okay, I'll be drawing the ray diagram for taking the object to be beyond 2f. So I take this point to be the starting point. This is the starting point, and I can mark the different positions here. Then we take it here. Okay, so this is how you have to draw. I'll be drawing it roughly, otherwise it's taking too much of time. You can draw it properly here. So it's your the first point. I'm taking this one to be 2f, this point to be f1. This is 2f1. A same equal distance to be equal to optic center, and then we can have here f2 and 2f. Now we can draw the lens. The center point of the lens should be the optic center, something like this. So this is our lens. we will show all the refraction being occurring through the center of the lens. So we will observe, or we will show you, we will show all the diagrams here. We will show all the diagrams through the center, to this point. Now, suppose we have the object beyond 2f. We have the object here which is beyond 2f. So we take two rays of light as studied earlier. Let's say the first ray of light taking parallel to the principal axis. So where will this ray of light pass? When I'm taking the ray of light parallel to the principal axis. Yes, what will be the point? Through which point? Will this pass through focus? See, I have taken a ray of light passing parallel to the principal axis, and the ray of light is passing through the focus. After refraction, the ray of light passes through focus. Then to understand the image, we take the second ray of light passing through the optic center. So from here we take another ray which passes through the optic center, and we can see the ray of light, it meets between F and 2F. See, the two rays of light, they meet between F and 2F. So we have formation of image. Here the image is formed between F and 2F. This was the object, and here we have the image that is formed between F and 2F. So what characteristics do we observe for the image? Ayonija, can you tell the image characteristics for this ray diagram?
So the image formed is real and inverted.
Yeah, image is real and inverted, and
Sir, and it's of same size and it is formed at between two F2 and 2F1. F2.
okay, image is smaller than the object. It's not the same size. Image is smaller than the object. That is, we will say it is diminished, and it is formed between F and 2F. So whenever we talk of image characteristics, we describe three things. We describe the nature of image, and here the nature of image is real and inverted. So image is real and inverted. Then we say its position and size. So the position of the image is between F and 2F. And what about the size? Size is diminished. It's smaller in size. So this is smaller or diminished. Anyone having any doubt with respect to this diagram? No one? Okay. Now, can you draw the ray diagram by keeping the object at 2F? So I'm also drawing here, and I want you all to draw the ray diagram for the object kept at 2F. Dharya,
Yes, sir.
are you drawing the diagram?
No, sir. I'll draw it once you are done with the whole thing.
Okay. So the same rules, you have to do the same rules. Here we take, I'm taking the help of the ruler. You can take the help of a ruler also, or anything, to mark the points. So the points are taken generally like this. They have to be taken equidistances. So if I take here my 2F, so I'm taking at 2 centimeter, I'm taking F. At 4 centimeter, I'm taking O. At 6 centimeter, I'm taking F1. And at 8 centimeter will be 2F. So let's mark the points here and make the lens. So here we have the lens. This is F1, 2F1, F1, F2, and 2F2. Right. So let us make our object at 2f. So now we make the object at 2f. So you just need to use your rules which we just studied. The two rules, that is, if you take a ray of light parallel to the principal axis, here I take a ray of light parallel to the principal axis. So after refraction, the ray of light passes through the focus. Then we draw the second ray of light, taking it through the optic center. So the second ray of light starts from the same point, passes through the optic center, and you see that it cuts at 2f. So we have image being formed at 2f. You should be getting the image formed at 2f, like this. So this should be the image. If you are using a proper scale, proper measurements, so you will get the exact measured value. You will get your image at exactly 2f. So here we have kept object at 2f, and now we need to put the image characteristics. So here we have the image characteristics, where the first point we talk of is nature, and nature of image is real and inverted. It's real and inverted. Then we talk of its position. It is formed at 2f. So everyone is making the diagram. Dhari, have you made the diagram?
Yes, sir.
Okay. Moksha, do you have any doubt? Since you are not present in the earlier classes, you are new here. So Moksha, are you getting all these concepts?
Yes, sir.
Okay. So if you are feeling any doubts or anything, you just speak up, or you can message with a private message in the chat section.
Okay, sir.
So your image, when the object is kept at 2f, the image is real and inverted. It is formed at 2f, and the size of image, it is of the same size. Same size as the object. So all those whose diagrams have been drawn will show their diagram through the camera. If your diagram is ready, I want to see your diagram.
Sir, 1 minute still to me.
Okay. So are you showing your diagram?
Sir, 1 minute.
I want to check all your diagrams. So starting with Aryan.
Sir, 1 minute, sir.
Ionija, is your diagram ready?
Sir, can you show the? I need to do the second one. Can you show it again?
Okay, I'll be showing it. Just first let me check all those who have done their diagram.
Sir,
Okay, Ionija, you are showing?
Yes, sir.
Okay, just show it. So this is object at 2f. Okay, real and inverted at 2f and same size. Okay, that's great. Okay, just make arrows in your range. Whatever range you have make a arrow over there. Okay, okay. And now Aryan. Just hold on. Yeah, Aryan, what are the characteristics there?
so each diagram, sir.
Yeah, just show it once. Show it once more. You have real and inverted between 2f2 and f2 and smaller. And the second one is, yeah, it's good. You can remove. Then, okay, Dhairya and Shubhansh. Shubhansh, can you show?
Sir, can you show the second diagram once?
Sir, I have not completed it. I have to see the second diagram.
Okay, we can continue again, I think. I wanted to check for Moksha and
Sir,
Sudhamshu.
sir,
Sir, actually my camera is not working properly. I will show you
Just
next
one
time,
minute.
sir.
I think I have notification by my speaker not working. Just hold on for 1 minute. Ah, 1 second, let me use some other speaker. Okay, just check anyone. Aryan.
Yes, sir.
Okay, now you're audible. Now we can continue. Yeah, Subhansh and Moksha. Moksha, have you done
Sir,
your? Yeah,
my
Moksha.
camera is not working, sir. I will send you photo.
Okay, so just send the photo to my number, not in the group.
Okay, sir.
Subhansh.
Sir, I have not completed it. I want to see the
Okay,
second one.
okay. And Sudhanshu, what about you?
Sir, after the second one.
How much? Okay, see here, I have reshared the screen for you to see the diagrams. So these are the two diagrams. In the first case, the object is placed beyond 2f, where we are getting a real inverted and diminished image. In the second case, we have placed the object at 2f, so we are getting the image at 2f. The image is obtained at 2f. The rules which we are using for the rays, they are same for both the diagrams. That is, a ray of light coming parallel to the principal axis passes through focus, and a ray of light passing through optic center, it passes undeviated. Now let's see the third case when we have the object placed between f and 2f. So the next one is object between f and 2f. So you have to use the same rules. So how many of you can draw this diagram without any help? I think so there are some of you who can draw the diagram without me drawing here. If you can draw, so you should start drawing the object between f and 2f. Remember to mark the points appropriately.
Sir, the image will form beyond 2f, sir,
Okay.
at infinity, I guess.
Yeah, so it is formed beyond 2f, right?
Yeah, sir.
Okay. So not at infinity, we don't call it infinity, it is beyond 2f. Let's
Okay,
put
sir.
here, okay. So we put here the points. Let's say this one to be the optic center here. Then we take the other points like here we will have f, here we will have 2f. So the same we get on the other side, 9 and 12. So let's draw the lens here. See, I'm drawing the lens by a free hand. You should be using your compass and everything. You should be using your geometrical equipment for drawing the lens and hence obtaining this perpendicular line which passes through the optic center. Now here we have f, 2f. This one is the optic center, then f2 and 2f. So let's take the object between f and 2f. You can take the object anywhere between f and 2f. So here we take the object between f and 2f. Now let's take the two rays which are passing parallel. One of the ray we will take passing parallel to the principal axis. For example, we take this ray passing parallel to the principal axis. So this ray passes through the focus. The second ray we take passing through the optic center. So we have the second ray passing through optic center. And we see both the rays, they meet beyond 2f. So we observe here that image is formed beyond 2f. So here we have the image formed beyond 2f. So what can we say about the image characteristics?
That the image formed is enlarged, it is formed beyond 2f2 and it is real and inverted.
Okay. So this same thing, we have the object AB, the image formed as A dash B dash. We make here arrows in the rays and then write the image characteristics. So the image characteristics for this diagram. Okay, the very first one is image is real and inverted. And its position is beyond 2f. Okay, and about its size, the size of the image is enlarged. Got it? Image is real and inverted. It's beyond 2f and it is enlarged. So have you drawn this diagram?
Sir, wait.
Okay, what comments can you give about the magnification here? I want your comments about the magnification for this case. That what will be the sign of magnification? Since magnification is given by the formula height of image by height
So
of
it
object.
will be negative, right?
Okay. So in this case, we will get magnification as negative. And what about the value of magnification?
Sir,
Sir,
Will it,
negative.
will it be greater than 1 or less than 1?
greater than one, sir.
Greater
Yeah.
than once.
Yeah, magnification here will be greater than 1. So for example, you can have magnification at minus 1.5, minus 2, minus 3, minus 2.2. So all such magnifications will respond to this image or this ray diagram. Then the second last one, we keep the object at f1. So where do we get the image if we keep the object at f1?
Sir, sir, between F2 and 2F2.
Okay, that's not, we will not get the image between f2 and 2f2.
Sir,
Let's try
infinity
infinity. Yeah, it will be infinity. Let's try to draw the diagram. So try to draw the diagram for the object. Yes, we draw our take the points here 6, 3, and 0. Okay. Then here we take 9. Okay. Anyone is finding any way, or if you already know, so don't feel it bored. You should complete the diagram. I will check it. Your diagram should be complete. So this is our optic center O. We have here F1. This is 2F1, F2, and 2F2. Now let's make the lengths here. So we keep the object at F1. and again use the two rays. One of the light ray we are taking parallel to the principal axis, and the second light ray we will take passing through the optic center. So we will observe the ray of light which passes through the optic center. Is it passes parallel, and the second ray of light which was going parallel to the principal axis. So it will pass through the focus, and hence you will observe that the two light rays they become parallel to each other. So here we see that the two light rays they are parallel to each other. Okay. So this was your these were the incident rays, and finally we have the refracted rays. So we have here image formed at infinity. Image formed at infinity. Got it? Okay. What about the image characteristics for this case? Yeah. What about the image characteristics here?
Real and inverted.
Real and inverted, and
It is formed at infinity.
okay, formed at infinity. So we mention here image characteristics. It's real and inverted. And it's formed at infinity.
Then it is enlarged, no, sir.
Yeah, highly enlarged. It is highly enlarged. And then the third point we say it is highly enlarged. Highly enlarged. Now the second after this we have to draw a ray diagram for the object placed between O and F. Okay. So let us try to draw the ray diagram when we place the object between optic center and focus. Again in the same way.
Sir, I'm drawing the diagram, sir.
Yeah.
Sir, could you please show the previous one, sir?
Okay. It's here. Okay, so done this diagram.
So only 1 minute, sir.
Okay.
Completed, sir.
Okay.
Completed, sir.
Okay. So now see the next one. In the next diagram, we will be drawing the object to be between F and 2F. So again, we can take any of the points. Suppose if I take these points 10, I can take here 7, then 1, 4, 1, and here I'll be taking 13. So I'm taking 3 centimeter of difference. So let's take this one, our optic center, F1, 2F1, F2, and 2F. Okay. So we have a ray of light coming, we have the object placed between optic center and F. So for this special case, again we take the light ray, one of the light ray going parallel to the principal axis, and after refraction it passes through focus. The second ray of light we take to be passing through the optic center. So the two rays, they seem to be diverging and hence they do not meet each other. However far they may go, they do not meet each other. Okay. So if we extend these light rays in the backward direction, they appear to meet at a common point. So if I extend them like this, so the light rays, they appear to meet at some common point. See here, the light rays, they appear to meet at a point. And hence we can say that image will be formed at a point where they appear to meet. So what type of image is formed here?
Virtual and erect.
Yeah, here we have virtual and erect image. This is a virtual and erect image. And it can be formed anywhere behind this F. So behind focus, the image can be formed anywhere. So we write this as A dash B dash to be the image. Here we have A, B to be the object. So we say the characteristics, they are virtual and inverted. So virtual and erect. The image is highly enlarged or it's enlarged. It's bigger in size. We say image is enlarged. And about the position, so it is found before the lens. So before the lens, it can be found anywhere. Got it?
Yes, sir.
Okay. So anyone having any doubt? I think by the next class, you should be aware of all the ray diagrams of the concave and the convex lenses so that we can move on further to the lens formula. Okay. Okay. So by all of you, just practice all the ray diagrams. Goodbye.
Bye,
Bye.
sir.
Okay. Okay. I expect that all of you are there in that science support group. If you are not there, do join, and whatever doubts are there, you can send.